Hello students, good afternoon. This is Satish from Toppr. Today we are going to discuss in this session about differential calculus. So, let us get into it, let us solve a few questions from the past papers. Okay. So, the first question is on the differentiability of composite functions. You know what is a composite function, right? Like function is defined on the domain of the another function, right. So, f of g of x, f circle g x, somebody might say, or g of f of x, h of f of x, something like that, right. So, now the first question says that g is a function which is defined from R to R, the real number set to the real number set, which is differentiable. So, he is saying that g is differentiable. We already know that the functions, we already know about the functions which are continuous, which are differentiable, right. We know that every differentiable function is continuous, but not every continuous function is differentiable, because there are points like cusp or corners where the functions are not differentiable even though it is continuous. One simple example is you can take modulus of x, absolute value of x, which has a cusp at x is equal to 0 and it is not differentiable, right. So, here he is defining a function g which is differentiable, and also differentiable. When he says differentiable, it is differentiable everywhere, else he would have informed, or else defined some interval where it is differentiable. So, he did not say anything, that means it is differentiable everywhere on the entire real number set, and g of 0 is 0. So, when you substitute the 0 in the value of the function, you get 0, g dash is also 0 at 0 and g dash 1 is not 0. So, the gradient of the function g at 1 is not equal to 0, this is given, and then he defined one more function f of x, which is x by absolute value of x, or say modulus of x, times g of x. So, this is the definition of f of x. That is the definition of f of x when x is not equal to 0, because see here this is a piecewise function again, like it has two definitions. When x is non-zero, you will have x by absolute value of x times g of x, and when x is equal to 0, because division with 0 is not possible, right. That is the reason there is another definition for it, and it is 0. When x is 0, f of x is 0, and when x is non-zero, then the function's definition is x divided by absolute value of x times g of x. One more function is given, h of x, which is equal to e power absolute value of x. This is another function. So, these are so how many functions do we have here? We have 3, g, f and h. And then what is he saying, like then which of the following are true? So, we have to find out, like out of these 4 options, which are true is the question. Like he is saying, like the question, the option 1 says f dash is differentiable at x is equal to 0, h of x is differentiable at x is equal to 0, f of h of x is differentiable at x is equal to 0, and h of f of x is differentiable at x is equal to 0. So, these are the values, these are the statements which we have to verify whether they are right or wrong. So, for this what we have to do is you have to find out whether f at every function ka left derivative and right derivative at that given point, if it exists and equal or not, if it is differentiable at that point or not, is what we are going to find, right. So, come let us do it. So, let us do it in let us break it down into small steps. I have solved this sum in in small steps so that you understand it easily. So, I named it the first one as step 1. What are we going to do here? First we will find out f of x and f dash x, because we have to check whether f is differentiable or not. That means what? If f dash is existing at x is equal to 0 or not, that is what we have to do. So, for that, first what we are given is listed down there, like g of 0 is equal to 0 and g dash is 0 and g dash 1 is non-zero. So, that values I have listed it down there. So, g is given and this is the given information for us, right. Now, what do we want? F of x. F of x is what? x by absolute value of x into g of x. So, I am trying to find the value of x by absolute value of x. So, x by absolute value of x will be equal to 1 when x is greater than 0. When x is positive, these two values will be the same, the numerator and denominator will be equal, right, x and x. So, that will be equal to 1. And if it is less than 0, if this value of x is less than 0, means x is a negative value, then my numerator remains negative, but the denominator, since it has an absolute value, it goes to positive. So, negative by positive will become a negative value for me, that is minus 1, right, clear, right. So, this is the definition of x by modulus of x, but f of x is what, into g of x also is there. So, let us do that. Now, f of x is equal to g of x when x is greater than 0. Why? Why? Because f of x is x by absolute value of x times g of x, and x by absolute value of x has become 1 for us here. This is the value where it has become 1, this is 1. So, if that is 1, then you just multiply it with the g of x. So, g of x into 1 is g of x. So, f of x is equal to g of x when x is greater than 0. So, for all positive values of x, f of x and g of x are equal, they are the equal values, right. And then its value is already defined, that when x is equal to 0, f of x is defined as 0. So, for 0 it is simply 0. When it is negative less than 0, then f of x will become minus g of x, because you are multiplying g of x with a minus 1. So, you get negative, right. Now, let us see what happens if we differentiate, then f dash x is equal to g dash x, because f of x and g of x are the equal functions and I am differentiating them, their slopes also will be equal. So, I got f dash x and g dash x are equal, and its differentiation is 0 when x is 0, because f dash of x is derivative of 0, which is simply 0, and g dash x, negative g of x ka differentiation is simply minus into g dash x, right. So, differentiation is existing everywhere, like at 0, when greater than 0, equal to 0 and less than 0, clear. Now, what will we see is, if g dash x exists at x is equal to 0. Now, see, at x is equal to 0, what is happening for f dash x is what we are going to check now, right. So, f dash x is what is at x is equal to 0, f dash x is equal to 0, right. When x is 0, f dash, here f dash and g dash, these all are f dash x, this is f dash x, this is also f dash x, because this is the that is how the function is defined, that f dash is g of x. So, f dash x is g dash x, f dash of x is equal to 0 when x is equal to 0, and f dash of x is equal to minus g dash of x. Now, at x we already know that its value is 0. Now, let us see what happens to the left limit and left derivative and right derivative. What is the right derivative? X tends to h plus f dash of 0 plus h, right, which is nothing but for g whatever it is there, it is the same thing. So, because f dash and g are same when on the right hand side, like when it is positive, when x is positive, f dash and g dash are same, right. So, you get g dash of 0, which is 0. Even at the left derivative also, it is g dash of 0, which is equal to 0, because from left and both g is differentiable at x is equal to 0, that means g dash is existing at 0, and since f is equal to g, then we can say that f of x is differentiable at x is equal to 0. Is this clear? What we did here is, we found the value of f of x, then we found f dash of x. How did we? F of x is g of x or minus g of x, and g dash of x, negative g dash of x is nothing but 0. When you are putting x is equal to 0, g dash of 0 is g dash of 0 is 0, minus into g dash of 0 is again minus 0 is like 0, right, like you need not put a sign in front of it when it is 0. So, that is the reason the derivative is equal, like the left hand derivative and right hand derivative are equal. That is the reason f dash is differentiable here, because its left hand derivative, right hand derivative are equal to the derivative at that point, right. So, option A is correct, So, here first option is right, but it can have multiple options which are right. So, you have to go for the next one also. So, h of x is differentiable at x is equal to 0. So, let us find h of x. What is h of x? H of x is e power absolute value of x. So, h of x will be equal to e power x when x greater than 0, because x is positive, then it is always e power x, there is no change in it, right, and it will be 1 when x is equal to 0, because e power 0 is 1. When x is negative, it will be e power minus x, which is nothing but you can say 1 by e power x also, right. This is the definition of h of x. We have defined, like we have written h of x explicitly. Now, if you differentiate, h dash x will be equal to e power x, because d by dx of e power x is e power x, right. Then if it is 1, if I am differentiating, d by dx of 1, d by dx of a constant is always 0. So, the derivative is there 0, and if I differentiate e power minus x, it is minus 1 into e power minus x, which is nothing but minus e power minus x. This is the derivative. Now, let us check for its left hand and right hand derivatives for this h function, right. So, right hand derivative will be what? K tends to 0, because earlier we wrote h, and why are we writing here k? Because the function's name itself is h, that is the reason we are taking a different number k, right. So, k tends to 0 plus, means from the positive side of 0 we are approaching k, h dash of 0 plus k, and this value will be equal to 1. When you take this to 0, its value is equal to 1, e power 0 is 1, and the left hand derivative, when you are moving towards 0 from lesser values, means from negative values, then you have to take this as the function's definition, right, which is minus 1, because minus e power 0 is minus 1. So, what happened here? The left hand and right hand derivatives are not equal, and the derivative at that point has actually is also equal to 0. So, that is also not equal. So, what happens? H of x is not differentiable. So, if h of x is not differentiable, here he is saying h of x is differentiable. So, this condition is wrong, right. So, h of x is differentiable at x is equal to 0 is a wrong statement. Clear? What is the next one then? F of h of x is differentiable at x is equal to 0. F of h of x, it is a composite function, a function f defined on the range of h of x. So, let us see it. Now, f of h of x, how do we do this? We already know that h of x is greater than 0. H of x is what? E power absolute value of x. Whatever x value you take, e power, it is always a positive number. It will be it will never be a negative, right, anything power, and this e is a positive number, 2 point something is there. So, that number is always positive, right. So, this is always positive. So, what happens? We can simply say absolute value of h of x is always equal to h of x, there is no change in between them, right. Why we need this is when we define function f. That is the reason we are trying to check what will be the absolute value of h of x, because my definition of f of x is nothing but x by modulus of x into g of x. Now, what are we trying to find? F of, we are trying to write f of h of x. So, this value will be equal to what? When you write this, in the place of x I have h of x. So, it will be h of x by modulus of h of x times g of h of x, because for me x is nothing but h of x. That is the reason we are trying to find what will be the value of absolute value of h of x. What is the value of absolute value of h of x? Since h is always positive, h of x is always a positive function, the modulus of it is always equal to the function itself. So, there is no difference. That means, when I write the function f of h of x as h of x by modulus of h of x into g of h of x. These two are the same values, h of x and absolute value of h of x are always the same, there is no change in between them. So, this can be nullified like it is 1, then you simply get g of h of x. So, f of h of x is same as g of h of x, right, and then f dash of h of x. So, we are differentiating it because we want to check, what do we need to check? F of h of x is differentiable at x is equal to 0. So, to find that we have to differentiate it first. So, differentiating using the chain rule, you get g dash of h of x into h dash x, like you are first differentiating the function g and then you differentiate the function h. So, now where are we checking? This one we are checking at the point x is equal to 0. So, you need to put x is equal to 0. So, what happens when x is equal to 0? When x is 0, h of x is how much? 1. So, when x is 0, h of x is 1. So, that is the value we are going to substitute in here, right. So, f dash of h of 0 is equal to g dash of h of 0 into h dash of 0 equals to g dash of 1. What is 1? H of 0, h of 0 is 1. He is directly, instead of writing g dash of h of 0, he is writing 1, because that is what we define, right, h of x is equal to 1 when x is equal to 0. And finally, what happened? This is not equal to 0 because g dash of 1 is not 0 and h dash of 0 is h dash of, yeah, g dash of 1 into h dash of 0, and this g dash 1, what is g dash 1? G dash 1 is not equal to 0. When g dash 1 is not equal to 0, then your f dash of h of 0 is not equal to 0. But f dash of a function, see, f dash of a function is differentiable when its limit, when its derivative is 0 at x is equal to 0. But here what did we get? The same f dash f function, the same f function, we got its derivative as non-zero, right. That means it is not differentiable at this point, because it should be equal. See, the left limit, left derivative and right derivative should be equal to the derivative at 0, but that is not happening here. That is not happening here, it is not equal to 0 here. It is disproving what we proved here, like f dash of 0 is 0, but we are not getting that. F dash of something we are getting as a non-zero value. So, this is not differentiable at x is equal to 0, right. Next one, what is the next statement here? H of f of x is differentiable at x is equal to 0. H of f of x. H of f of x is, means h of x means what? E power modulus of x. So, e power modulus of f of x, and we already know that f of x is equal to g of x whenever x is greater than 0, whenever x is greater than 0. And here we are taking a modulus value, that means it is always positive. So, it will be simply equal to g of x, because there is no negative value we are considering, right. That is the definition, right, that is what we defined. F of x is equal to g of x, that is what we proved also, actually we found it. F of x is equal to g of x when x is greater than 0. So, since you are taking an absolute value here, this is always positive. So, modulus of f of x you can simply write it as g of x. Now, what happens if you differentiate this? H dash of f of x, e power g of x ka differentiation is simply e power g of x, and then differentiation of g of x is g dash x using the chain rule again. Now, what is the right hand derivative here? When you approach from the right side of 0, g dash of x plus k into e power g into x plus k. Now, it becomes 0, it is going to 0. So, g dash of 0, this value is 0, g dash of 0 is 0, 0 into something is 0. And the same way, the left hand limit also, g dash of 0 into e power g into x minus k, this is also equal to 0, because g dash of 0 is 0. So, using that we get both the values are zeros. So, we can simply say that h of f of x is differentiable at x is equal to 0. So, what did we get? We got options, except for the C, A, B and D are the correct options for this question. Got it, guys? If you have any doubts or questions, just leave a comment in the channel, YouTube channel, and I will get back to you. Okay. So, let us move to the second question. The second question says f r to r be a function such that f of x plus y is equal to f of x plus f of y. It is a function defined like that. Okay. For all x comma y belongs to real numbers, if f of x is differentiable at x is equal to 0. So, f of x is differentiable, this particular function f of x is differentiable when x is 0, then he is asking us to check f of x is differentiable only in a finite interval containing 0, or f of x is continuous. Okay, he is asking us to check whether f of x is continuous or not. F dash x is constant for all x belongs to R. F of x is differentiable except at finitely many points. So, he is asking us to check whether f of x is differentiable at everywhere except for finitely many points, means he is saying that like that there are some points where the function is not differentiable. So, you have to check whether it is completely entirely differentiable on the real numbers, or there are some points where it is missing the differentiability, and then you have to check whether it is a continuous function, and then you have to check whether it is a constant function f dash is a constant, and then f of x is differentiable only in a finite interval containing 0. This is what he is asking us to check. So, let us get into it. What is given? F of x plus y is equal to f of x plus f of y. Now, if I take x and y as zeros, because he said x comma y belongs to real numbers. So, it can be any number, right. So, I am taking both of them to be 0, then what happens? F of 0 plus 0 is f of 0 is equal to f of 0 plus f of 0. From this I can simply say f of 0 is equal to 0. Why? Because f of 0 is 2 times f of 0, and do that algebra like sending it to the other side, then 2x minus x is simply x, which is equal to 0. So, f of 0 is 0, that is first value we found. Now, what we will do is we will take this expression, this equation, and differentiate it with respect to one variable, like you can say you are doing a partial derivation or something, okay, treating y as constant. So, we are not taking y as a variable here, we are just trying to differentiate it with respect to x. When I differentiate, this is a function, right. So, I do not know what expression is there inside the function. So, I am just writing it as f dash of x plus y. X plus y is a number, it is a variable for me, right, like x is a variable and y is a constant. So, finally, it is an expression, small expression, which is there in the function. So, I am differentiating it. So, f dash of x plus y. Now, I am differentiating the right hand side, since we took y as a constant, that is eliminated, it becomes 0, right, differentiation of constant is 0. What is left now? F of x, its differentiation is f dash x, right. So, now if I put x is 0 in this, what am I getting? F dash of y is equal to f dash of 0, f dash of y is equal to f dash of 0. Then if I want, I want my f of y, I am trying to find f of y, what will I get? So, how can I do that? Like if I integrate a derived function, I will get back the function, right. So, I am integrating this on both sides with respect to y, then f of y is equal to, I am integrating with respect to y. So, y should be the variable which I am getting. So, y times f dash of 0 plus a constant c, plus a constant c. Now, if you take y is equal to 0, then we get constant is 0, means when the function's value, the variable is 0, then your function becomes f of y is equal to y into f dash 0, y into f dash 0, and this f dash 0 is what? Again some value, some k, m or whatever value is there, right. It is some real number, differentiation by substituting some value in it. So, I can simply say f of y is equal to some y into k, this is some value k, y is the variable here now, right, because we integrated it with respect to y, taking y as a variable. So, what did I get? Like f of y is equal to k into y, right. Similarly, what we can say, f of x is also equal to kx, means if I take here, if I take y as constant and x as a variable, I mean y as a variable and x as a constant, I get to this equation, right. So, if you look at this, f of x is equal to kx and f of y is equal to ky, right. Now, f dash of x, if I do f dash here, what am I getting? Simply k, right. And if you look at this, this is a if you look at this, kx is a linear function, it is a line, right, like y is equal to mx or something, like it is a linear function which is passing through the origin of the axis and it is continuous, a line, it has no endpoints, it is a line and it is continuous constantly, you know, there is no breaks in it, it is a linear, every linear function or a polynomial function are always continuous, right. So, this is a line always and it is continuous. So, you can simply say the function f of x is continuous, right, because f of x only we are writing it as k into x or k into y you can write, right. In the same way, when you differentiate this you get f dash x is equal to k, f dash x is k. So, first one we found is it is a continuous function and then it is also a constant. When you differentiate a linear function you get only constant because the variable gets eliminated, right, like here if I differentiate x goes off and I simply have f dash of x is equal to k. So, what do we have now? F is f dash of x is constant for all x belongs to R and also f is a continuous function. So, I can say that f of x is continuous function and f dash x is constant. So, B and C are for now correct answers for me. Let us check about the others. Yeah, what are the others saying? F of x is differentiable only in an infinite interval containing 0. So, see it is saying like it is differentiable only in a limited interval, but that is not possible because it is a line, the line passes through the, it is a line which is passing through the origin and it is differentiable everywhere. So, the rule A, the condition A is ruled out because he is saying only at finite intervals of containing 0. So, you need not check for that, that is false straight away, right. And then D, what does D say here? F of x is differentiable except at finitely many points. He is saying there are some points of points where the function is not differentiable, but just now we discussed it, right, like it is a linear function and it is differentiable everywhere. So, that is always wrong. So, this is wrong and this is wrong. So, only these are the two options which are right. Okay. Now, let us go to the next question. Okay. So, I think so far it was like complete abstract and theoretical, not much numerical calculations were involved so far, right. Like for this maybe you might feel a bit relaxed because there are some calculations which you understand easily. It is a polynomial function. So, when it is a polynomial function it is continuous. Also g of f of x is equal to x and h of g of x is equal to x for all x in R. So, he defined one more function h on this g and f. Okay. So, let us see what we have to for all in, then he is asking us to find the values of g dash of 2, then h dash of 1, h of 0 and h of g of 3, right. Means he is asking to check whether these are equal or not, these are the values given. So, you have to see whether they are equal or not. For this what we have to do? First we have to find g of x, then differentiate it, then put the value 2 in there. Similarly, h of x you will find, differentiate it, put a value 1 and then here you directly substitute the values. So, for g dash 2, so let us see, g of f of x is equal to x is given to us and we want g dash x. So, I am differentiating it on both sides with respect to x. So, what do I get? G dash of f of x into f dash x using the chain rule is equal to differentiation of x is 1. Now, to find g dash of 2, I want g dash of 2. What should I do? G dash of 2 means what? My f of x must be equal to 2, right, then only I get g dash of 2 here. I can substitute 2 here means f of x value should be 2, right. So, we need to find a value at which f of x is 2. For that f of x value is given to us x cube plus 3x plus 2, we will substitute here and say it is equal to 2, right. F of x equals to 2 means x cube plus 3x plus 2 is equal to 2 and factorizing it you will get x is equal to either 0 or square root of minus 3, and that is again complex root. So, we are not going into that, it cannot be imaginary number. So, x is equal to 0 is the only value where f of x value is equal to. It is clearly it is visible, right, it is evident here, like if you put 0 and 0 directly 2 you get. But why did we do this is there might be some other points where it is equal to 2 again. If there are more than one point, then you have to do at both the points, right. So, x is equal to 0. Now, I have to put x is equal to 0 here. Also, f of x is given to me, I will find f dash, because I want f dash of 0 also. When I am taking x is equal to 0, f dash of 0 also I need, because if I put here f of 0, g dash of f of 0 into f dash of 0. But what is f dash of 0? That is the reason we are finding it here. F dash of x is what? 3x square plus 3, using that power rule. So, 3x square plus 3 and put x is equal to 0, you get 3 as the value. Now, you can find the value of g dash of 2. How? Substitute x is equal to 0. So, g dash of f of 0 into f dash of 0, which is equal to 1, that is the equation. We are solving this equation now. How are we solving? This is nothing but g dash of 2, right, because f of 0 is already 2. So, g dash of 2 times f dash 0 is 3, substitute that here, is equal to 1, which implies g dash 2 is equal to 1 by 3, right. But what did he give? G dash of 2 is equal to 1 by 15. So, first option is not correct. Clear, guys? So, the first option failed. What is the second option? H dash of 1 is equal to 666. I think it is easier to find h of x before h dash of 1, because anyways we are going to find h of x, right. So, let us see which one we will get first. Try to find the, so what are we trying to do is we are trying to get the function h of x explicitly, like eliminating these all will get them into the variable x, right. So, what I am doing is, this is the given function, right, h of g of x, which is equal to x. So, I will put f of x, I will replace f of x, I mean replace x with f of x, so that, see now why doing that, what will we get is, see here, it is interesting actually, h of g of f of x is equal to f of x, right. Now, g of f of x is what? X. That is the reason I am substituting, I am replacing x with f of x. Now, what will I get? G of f of x will become simply x for me. So, this will become, what will this become now? H of g of f of x will be simply x, right. So, h of g of x will come for me. So, h of g of x will be equal to f of x, right guys. So, what are we doing? G of f of x is x. So, instead of g of instead of x I am putting in, instead of x I am putting in f of x. So, g of f of x will become x for me. So, I get h of g of x is equal to f of x. Let me write it maybe. For example, I will write it here, see, h of g of x, this is given as x. I write f of x in the place of x. So, h of g of f of x is equal to f of x, right. Now, this value will become x, because g of f of x is equal to x. So, what do I get? H of g of x is equal to f of x is what I am going to get, right. So, h of g of x is equal to f of x. Again, what we will try to do is we will put f of x in the place of x again. So, what I am trying to do now, this will become h of g of f of x is equal to f of x. In the place of x I am writing f of x. Now again this h of g of f of x will become x. So h of x is simply equal to f of x, right, means we found the value of h of x explicitly in terms of other functions, clear. So this is h of x which is equal to f of x. Now you can differentiate, right. What are we trying to find here actually? H of 0. So h of 0 means f of x. First we will find f of x because that is h of x, right. So f of x is, in the place of x I have to put the entire expression x cube plus 3x plus 2. So I substituted this in the place of x everywhere, right. Then h of 0 is simply substituting 0, and then you simply get this one is here these two terms get vanished like 0 and 0. So what is left is here 2 cube is 8, and here it is 3 times 2 is left, which is 6, and this is 2. So its value is 16, 2 plus 6 is 8, 8 plus 8 is 16. So our option C is correct. Instead of finding that B, we directly came into C, because h of x we found. Now we differentiate it. H dash of x is f dash of f of x into f dash of x. See, if you differentiate the whole thing, it will take a longer time, right. So instead what you can do is h dash of 1 will be equal to what? F dash of f of 1 into f dash of 1. Now we already know f dash of, it's easy to find f dash x, right. F dash of x is what? 3x square plus 3, and f dash 1 will be 6. Just substitute those values f of 1 and f dash 1 in this, and then f of 1 also you have to find, because f dash of f of x times f dash of x. F of x is f of 1. So what is f of 1? Put here 1 and your value is 6, right. So substitute those values and you get the value is equal to 666. So option B is also correct. Option B and option C are right, and so far option A is the only one which is wrong, right, for us. Now let us see for the D. H of g of 3 is equal to 36. H of g of x is equal to f of x. That is what we just now did, right, like h of g of x is equal to f of x. See, we are, this is all interlinked. We are using the definitions which we have derived in the previous part to solve the next part. This is the smart way of solving a question, guys. Okay. So now g of h of g of 3 will be nothing but simply f of 3. Substitute 3 in this one and see if it is equal to 38 or not. Then if it is 38, it has come 38. So 3, what is he gave? Yeah, he gave 36. So it is 38, means if you substitute here you will easily get it, like 3 cube and 3 into 3 plus 2, if you do, you will get 38, not 36. So this is also a wrong option. So here so far we have got B and C are the correct options and A and D are the wrong options here. Understood, guys? Let us go to the next question. Okay. F r to r is a thrice differentiable function. You can differentiate it 3 times, and also given that f of 1 is equal to 0, f is a function where its value is 0 at x is equal to 1, and f of 3 is equal to minus 4, and f dash f x is always negative. That is what is given, f dash is less than 0. For all x belongs to half and 3. So this is less than 0 in this interval, right. That means what? It is a decreasing graph in this particular interval. Slope is negative means the graph is decreasing, right. Also he defined one more function, small f of x, which is equal to x times capital F of x, x times this function, the given function, right, for all x belongs to R. Then he is asking us to check which of these statements are correct. F dash 1 is less than 0, f of 2 is less than 0, f dash of x is not equal to 0 in this interval, like 1 comma 3. 1 is not, see, observe very carefully, 1 is not included and 3 is not included. Open intervals, these all are open intervals, guys, you have to pay attention to that. And D, f of x is equal to 0 for some x belongs to 1 comma 3. See, one simple example or simple situation I will tell you. If this is a closed bracket and suppose f of x is equal to 0 at 1, this option would be right. If it is an open bracket and f of 1 is equal to 0, then this option would be wrong, because at 1 it is 0, but not in the interval 1 comma 3, because 1 is not included there, right. Values after 1 are included. So, that is the reason you have to pay attention to these brackets like closed or open intervals and stuff, right. So, now let us see what we can do, like we have to find the functions values like small f, right. So, what is given? F dash of x is given as negative in this interval, that means it is a decreasing function. Also he gave that f of 1 is 0 and f of 3 is minus 4. So, what is he saying here is from minus means from 1 to 3 the values are 0, from 0 it is going on to, from 0 it is going to minus 4. So, the graph is decreasing. So, if you see clearly, the graph is decreasing from here to there, and how can I say, if these two are the only values given to me, I cannot simply say that the graph is decreasing, because it might have taken a turn somewhere and again come back, right. But f dash of x is completely or permanently negative in this interval. Throughout this interval, he is saying throughout this interval it is negative, and half and 3. So, 1 comma 3 is definitely subset or equal to this interval, because half is further to 1, right. So, that means this value in this interval it is decreasing, that means 1 comma 3 also it is a decreasing function, it is constantly decreasing, clear. So, its values are always negative, because its starting value is 0, from there it is always decreasing, that means the values coming after that should be negative values, whatever values you take are negative values. That is the reason f of x, that is the reason we can say f dash of x is negative. Why? Because f of x is x into f of x is given to us. If we differentiate f of x plus x times f dash x is anyways negative, right. So, this entire value is negative, correct. Then f of x, what are the values of f of x? F of x values also should be negative, because the starting point is at 0, the f of 1 at 1 the value is 0, at x is equal to 1 the graph is starting over there, and then it is constantly decreasing, it is continuously decreasing until 3, that means all the values should be below x axis. That means this is also a negative function, this is negative value, this is negative value. When you add both of them you get a bigger negative, that is the reason f dash of x is always less than 0. Is that clear so far? F dash of x is less than 0. F dash is less than 0 means f of x is also a decreasing function. Can we say that f of x is also a decreasing function, since f dash is less than 0. Next, f dash of 1. So, what are we supposed to find here? We have to find f dash of 1. So, for that f dash of 1 will be equal to what? 1 times, if I substitute here, f of 1 plus 1 times f dash of 1. Now, f of 1's value is 0 plus f dash of 1, x is anyways 1, so you multiply it with or do not multiply, it is the same thing. So, f dash of 1, what is f dash of 1? F dash of x is less than 0 in this interval, means f dash of 1 is also negative, that means f dash 1 is negative. So, f dash of 1 is negative, less than 0 is a correct option for us. So, what did we do? We did find the value, of f of x in terms of x and the bigger x, and then we have derived it and found the value whether it is decreasing or increasing, right. So, f dash of 1 is always less than 0. Next one is, what is the next case? F of 2 is less than 0. So, you have to find f of 2. Now, f of 1 is in this if you substitute 1 here, 1 into f of 1 which is 0, and then f of 3